Paris hides a secret. Its beauty is also a story of forces, materials, and very clever tricks. From massive iron lattices to glass pyramids perched on ancient stone, every landmark here had to solve a problem: wind, weight, or the need to amaze. The city feels both timeless and engineered, where salons and science share the same streets. Today we'll peel back the facades of 5 iconic Paris sites and show the engineering that made them possible in a way you can actually picture. From citywide scale to a single iron giant, let's zoom into the lattice that made Paris touch the sky. They built the Eiffel Tower because Paris needed a bold answer to the question, how do you go up without toppling? At over 330 meters with a base nearly 125 meters across, the tower is essentially 4 legs leaning into each other, forming a giant, breathable truss. Wrought and puddled iron, about 7,300 tons of it, is arranged into thousands of smaller members joined by roughly 2.5 million rivets. That's like stitching a flexible coat of mail that can bend with wind. Deep concrete piles and a raft foundation anchor those legs into the river plain soil, so the sideways push from gusts becomes a manageable whisper instead of a shove. The curved arches at the base do more than look graceful. They channel loads inward and reduce lateral thrust. Up top, observation decks step back like a tapered mast, lowering wind pressure. Standing beneath it, you feel the mechanics. Air moves through the lattice, light pours in, and the whole thing acts like a metal tree planted firmly into Paris. From an iron skyscraper to glass and stone, here tradition meets a modern insertion that flipped a courtyard. The Louvre has been growing for centuries, but the moment the glass pyramid landed in 1989, it taught Paris how to balance old weight and new transparency. The palace is a stone giant. Imagine over 200,000 cubic meters of carved masonry holding up long vaulted galleries, while the pyramid is a 21.6-meter steel and glass needle planted in the middle of a classical court. Its skin is just 603 rhombus and 70 triangle panels, but beneath them sits a 95-ton steel space frame that transfers loads down into a concrete and stone substructure. The trick was respecting the museum's heavy medieval foundations. Engineers tucked the pyramid's support into an underground masonry base and the carousel level, so light could flood the courtyard without unsetting centuries of load paths. Inside, long galleries behave like veins, circulation paths that guide millions of visitors through vaults, while modern interventions hide stairs, elevators, and climate systems below grade. The result feels like a museum that learned how to breathe. From the Louvre's courtyard light to a single monumental vault, a triumph of stone and compression. The Arc de Triomphe answers a very old structural question. How do you make a hole in a wall that still carries the sky above? At about 50 meters high, this limestone monument is a textbook case of compression. The masonry, roughly 36,600 cubic meters, works by pushing forces along curved paths. The barrel vault of the main arch channels weight down into 4 massive piers, turning vertical pressure into lateral thrust at the haunches. Those outward forces are balanced by the mass and footing of the piers and the deep foundations below, so the arch doesn't spread. Inside, 284 steps coil upward through compact chambers, a reminder that heavy structures often hide surprisingly efficient circulation. The stone is forgiving, it wants to be in compression, so sculptors and engineers teamed up. The reliefs aren't just decoration, they live on the faces of load-bearing walls. If you listen at the base, you can almost hear the centuries of footsteps that proved the design. If you're enjoying this journey, don't forget to like the video and subscribe to our channel for more city deep dives. From imperial stone to nightlife's ironwork, here the architecture is theatrical and structurally playful. The Moulin Rouge is a tiny theatrical machine hidden in the city, where iron trusses and a painted windmill put on a show. The facade spans about 36.5 meters, while the mill itself rises roughly 28 meters with blades spanning about 12 meters, more ornament than engineering problem, but the building's real work is the auditorium inside. An iron truss roof, supported by an iron frame and lighter masonry shell, creates an open 25-meter span for the stage and audience, letting sound and light fill the space without heavy columns getting in the way. Wind loads hitting the mill were tamed by connecting the decorative frame back into the roof diaphragm, so gusts transfer into the whole building rather than wobbling the blades. Over the years, zinc and slate roofs, electric lighting retrofits and periodic renovations kept the cabaret structurally sound while its performances stayed daring. The Moulin Rouge proves that structural decisions can be part of a show, sometimes literally. From boisterous cabaret to a quiet hilltop, now we climb to domes that keep their own silence. Perched at Montmartre, Sacré Cœur feels like a fortress of light. Its white Château Landon travertine seems to glow, and it's held together by old-school stone logic. The basilica's main dome and campanile reach about 83 meters, and the dome's 16-meter diameter channels its weight along curved vaults into foundation pilings below. Think of the dome as a giant umbrella. Its curve takes the load and funnels it down the ribs into piers. The trick is handling the sideways, or lateral, thrust at the drum where the curve wants to push out. Thick masonry, buttressing geometry, and deep pilings prevent that spread. Inside, the volume, around 28,000 cubic meters, feels human-scaled despite the massive stone, the effect of carefully sized arches and vaults that shape light and silence. Even the Savoyard bell, almost 19 tons, sits within a tower engineered to carry that concentrated mass without shuddering. This is stone architecture at its patient best. Paris is a city where poetry and physics shake hands. Iron lattices that breathe, glass that sits on stone, and domes that translate weight into quiet grace. Each landmark we visited balances a practical problem with an aesthetic choice, proving engineering can be beautiful. Which city should we decode next? Tokyo's seismic secrets or Rome's ancient concrete miracles? Tell us in the comments, and don't forget to share this with someone who loves architecture.